Hi everyone, my name is Louisa, and today I'm going to be talking a little bit more about circuits and especially how we can find current and voltage for different loops of a complicated circuit. So here I've drawn a pretty simple circuit that has two loops in parallel right here, and it's a very useful circuit for demonstrating things because it also has these two resistors in parallel. So what we're going to be talking about in this video is we're going to look at how current varies throughout this circuit and also how the voltage varies. Now when I say how those things vary, I'm talking about different elements of the circuit that are going to have different values. For example, this resistor right here may have a different voltage going across it than this resistor right here. And we're going to talk about when that's true and why. So let's start off by talking about current. I'm going to try and make this fairly intuitive and easy to follow. So the rule about current is that when you're traveling down a path, current is going to be constant along that path. Let me clarify that a little bit by saying that I'm talking about resistors here. So what I'm saying is that if you have two resistors in series, like right here, they're going to have the same current flowing through them. The reason I wanted to clarify that is because I realized that I drew this line over the entire loop here, and I don't want you to get confused by thinking about the current in the wire here or here, because that is something a little bit different. What we're mostly concerned with is the current flowing through resistors. And the current flowing through two resistors that are in series is going to be the same. Now that means that two resistors that are in parallel, let me just draw a second circuit here just to visualize, they may have different currents. If this resistor and that resistor have the same voltage across them, but they have different resistances, R1 and R2, they will have different currents flowing through them. And you can think of it this way. If those two resistors have the same voltage pushing current through them, and this one has a much higher resistance than this one, a lot more current is going to flow through this one because it's much easier for current to flow through it. So that's how you can tell that they will have different currents if they're in parallel. If they're in series, then the voltage pushing them is the same. So even if one has a much higher resistance, they have to go through both of them, so the current will be constant. So the rule for current is that it's the same for resistors in series. Now let's look at voltage and determine that rule. Since voltage must drop according to the voltage of the battery, when you complete a loop, we can tell that this loop, the one I've just drawn in gray, and this loop, the one I've just drawn in green, must have the same voltage drop. So that means that the voltage across R2 and R3 is the same as the voltage across R1. Now that alone is enough to determine our rule, which is that voltage is the same for resistors in parallel. However, it is not the same for resistors in series, and that's because it takes more voltage to push current through a very large resistance than it does to push current through a small resistance. So even though these two are in parallel, even though these two are in series, it's going to take a lot more voltage and cause a much bigger voltage drop to push current through this resistor. That's how we know that voltage for two resistors in series is not the same, unless they have the same resistance. But the important thing to know is that current is necessarily the same for resistors in series, and voltage is necessarily the same for resistors in parallel. And now I'm just going to fill in this chart, which is a tool that I find helpful for remembering this. I just filled in that voltage is the same in parallel and current is the same in series, and now I just want to note that voltage in series can vary, and it usually will. If the resistances are different, it will vary. And current for resistors in parallel can vary. Same thing, it usually varies. As long as the resistances are different, it will vary, and most of the time your problems will have different resistances to make them a little bit more difficult. So if you use this chart and these rules, you can find out a lot of different things about a circuit.